Hello friends, last lecture we learned about non-exact differential equation case 1 and case 2. In this session we learn non-exact differential equation case 3 and case 4. So first case 3, if given differential equation is homogeneous form with mx plus ny which is not equal to 0, then integrating factor is 1 upon mx plus ny. In case 4, if given differential equation is the form of f1 xy of y dx plus f2 xy of x dy equal to 0 with mx minus ny not equal to 0, then integrating factor is 1 upon mx minus ny. Case 3 we easily identify because given differential equation is homogeneous form. Last lecture we already solved the examples of homogeneous differential equations, and case 4 which is also easily identified because whatever the function in form of x and y both, that term which is multiplied with x, whatever the function which is another function which is in form of x and y which is multiplied with x and dy, that type of form in form of question, then we can use case 4, and homogeneous differential equation then case 3. Let us start with one example. Example is xy minus 2y square dx minus x square minus 3xy dy equal to 0. So first we check given differential equation is homogeneous or not. We learned already in last lecture. So first term has a, we check total number of count of variables. Then here x and y both has power 1. Then total variable 2. Moreover here y square, that is also 2. Then third term has also total count of variable 2. Fourth term has also total count of variable is 2. Each and every term has a same count of variable. Then we can say that given differential equation is homogeneous. Then we write which is homogeneous differential equation. This example also we solve as a homogeneous differential equation method which is learned already. Now that term which is indicated by m xy minus 2y square, that term which is indicated by n x square minus 3x square. Then partial derivative of m with respect to y, then we get x minus 4y, and partial derivative of n with respect to x, then we get 2x minus 3y. Then both has different values. Then we can say that del n by del y which is not equal to del n by del x. Then our differential equation is non-exact differential equation. Then convert this non-exact differential equation to exact differential equation form. But here we use case 3 because that is homogeneous differential equation. Then homogeneous differential equation, then integrating factor is 1 upon mx plus ny. First find integrating factor. Before that we just find only value of mx plus ny, and that value must be not equal to 0 in both the cases. Then substitute the values of m and n. Then here m is xy minus 2y square into x plus n is x square minus 3xy into y. Just expand this. Then we get x square y minus 2y square x plus x square y minus here something here n has a minus sign, then we consider with sign, that is minus, then here answer is minus, same as both has different values. Then n has a first term which is minus, another term which is plus, then expand this. So first term which is minus, another term which is plus, then x square y cancel, then subtraction this, then we get xy square which is not equal to 0. Then our integrating factor is RF equal to 1 upon mx minus mx plus ny, then which is 1 upon xy square. Then converting non-exact differential equation to exact differential equation, then multiply with IF our given differential equation, then we get whatever the integrating factor we get in all four cases, multiply with our given differential equation, then we can get our exact form. Then simplify this term, x cancel, y cancel, then 1 upon y square cancel, then minus 2 by x dx minus x cancel, then x upon y square minus x cancel, y cancel, then 3 by y dy equal to 0. That is our equation number A, which is exact differential equation. If we have doubt that it is exact or not, then we just find that term indicated by m star, that term indicated by n star, then partial derivative of m star with respect to y, then minus 1 upon y square, and partial differentiation of with respect to x, minus goes inside, then minus 1 upon y square and 0, then both has same value, then we can say that given differential equation is exact differential equation. Now solution of exact differential equation, then we have formula. The solution of exact differential equation has integrating y constant m dx. The solution is general solution integrating y constant m star dx plus terms of n star which are independent of x, dy equal to c. Then integrating y constant m star, then that term indicated by m star which is 1 upon y minus 2 by x dx plus integrating this term has purely y variable we consider only. The minus goes inside, minus minus plus, then we can write 3 by y dy equal to c. Then integrating, then first term is x by y minus 2 ln x plus 3 ln y equal to c, where c is an arbitrary constant. According to the properties of logarithm, we can write ln y raised to 3 equal to c. Now, if we want to simplify that term, then here we write ln e raised to xy. According to the properties of logarithm, x by y goes above, then ln e value is 1 minus ln x square plus ln y cube equal to c. Then according to the properties of logarithm, addition form, then multiplication, and subtraction form, then division. Then we can write ln e raised to x by y into y cube divided by x square equal to c. Then taking anti-log, then e raised to x by y cube upon x square equal to c, because here c or whatever e raised to c, which is equal to y, e raised to c. Then where e raised to x by y cube by x square equal to c, where c equal to e raised to c, which is constant, then x square goes this side, then e raised to x by y into y cube equal to c x square, where c is an arbitrary constant. Another example is x square y square plus 2 of y dx plus 2 minus x square y square x dy equal to 0. In this example, y square, here this form of this equation, which is in form of x1 of f of xy, this form is f1 of xy, which is multiplied with y into dx. Here this function, which is indicated by f2 of xy, which is multiplied with x, dy equal to 0. Then we can say that in example we use case number 4. Then first we check differential equation is exact or not. That term indicated by m. Then m equal to y goes inside the brackets, then y cube plus 2y. Here x goes inside the brackets, then n indicated by 2x minus x cube y square. Then partial derivative of n with respect to y. Then we can get 3x square y square plus 2, and partial derivative of with respect to x, then 2 minus 3x square y square. Both has different value. Then we can say that our differential equation is non-exact differential equation. Here del m by del y, which is not equal to del n by del x, then we can say that our differential equation is non-exact differential equation. Then according to the case 4, we find the first mx minus ny, and that answer must be not equal to 0. Then multiply with m as a x, then value m is has, and value of n is 2x minus x cube y square, which is multiplied with y. Simplify that term. Then x goes inside the brackets. Then x cube y cube plus 2xy minus y goes to inside the brackets, and minus 2xy minus minus plus x cube y cube, then 2xy which is cancel out, then we get value of 2x cube y cube, which is must be not equal to 0. Then integrating factor is 1 upon mx minus ny, which is 1 upon 2x cube y cube. That is our IF. Now these are the steps for solving the non-exact differential equation to exact differential equation. Convert for that. Now for converting the exact differential equation, we multiply with IF to our question. Then our example IF, which is here m as a y goes in, this y goes inside, then we have x square y cube plus 2y multiply with 1 upon 2x cube y cube, 1 upon 2x cube y cube dx plus 2x minus x cube y square upon 2x cube y cube dy equal to 0. Now simplify this term. Then y cube cancel, x square cancel. Then we get 1 upon 2x plus 2 cancel, y cancel. Then we get 1 upon x cube y square dx plus here 2 cancel, x cancel. Then 1 upon x square y cube, x cube cancel. 2 as it is, y square cancel. Then 1 upon 2y dy equal to 0. That is our equation number A, which is exact differential equation. Now solution of that exact differential equation is the solution of that exact differential equation is integrating y constant m star dx plus terms of n star which are independent of x dy equal to c. Substitute the values of m star, that is 1 upon 2x plus 1 upon x cube y square dx. Here in n star we consider purely y term. So first term has x into y. We cannot consider this value. Consider only minus 1 upon 2y. Then integrating that term, then 1 by 2, 1 upon x integration has ln x plus 1 upon y square as it is, x raised to 3, then power raised to x raised to minus 3 plus 1, then minus 3 plus 1 minus 1 by 2 ln y equal to c. Then simplify that term, then 1 by 2 ln x minus 1 by 2 1 upon x square y square minus 1 by 2 ln y equal to c. Then taking to LCM, then ln x minus 1 upon x square y square minus ln y equal to 2c. Then according to the properties of logarithm, first and third term, which is ln x by y, minus 1 upon x square y square equal to 2c, where 2c equal to c dash. We can write ln x by y in terms of, it's okay, we no need to simplify that term, where c dash is an arbitrary constant. Another example is x square y dx minus x cube plus xy square dy equal to 0. Here first we check that here total count of variable is 3, first term, here 3, 2 plus 1 3. Each and every term has total count of variable is same. Then we can say that given differential equation is homogeneous. This example we can also solve method of homogeneous differential equation, that is indicated by m, which is x square y, that is indicated by n, that we consider sine, then x cube plus xy square. Now partial differentiating of m with respect to y, then del m by del y equal to x square, and partial differentiating of n with respect to x, then we get minus 3x square minus y square, then both has different values, means we can say that del m by del y, which is not equal to del m by del x, which is our non-exact differential equation, means convert this non-exact to exact form. Then in homogeneous differential equation, then we apply case 3. So in case 3, first we find mx minus ny, then whatever the m which is multiplied with x, then we get x cube y, plus whatever the n which is multiplied with y, then minus x cube y minus xy cube, then expand the bracket, x cube y minus x cube y minus xy cube, this both term are cancel out, then we get minus xy cube, which is not equal to 0. Then we find integrating factor, then integrating factor is 1 upon mx plus ny, then minus 1 upon xy cube. Then for converting the non-exact to exact form, we multiply integrating factor to our given differential equation. Then we get exact differential equation, minus minus plus, then x cube upon xy cube plus xy square upon xy cube dy equal to 0. Simplify this term. X cancel, y cancel. Then we get minus x upon y square dx. X cancel, y cancel. Then x upon y square. In this term, 1x cancel. Then x square upon y cube. X cancel. Then we get, y square also cancel. Then we get 1 upon y dy equal to 0, which is exact differential equation. Now, converting this, we find solution of exact differential equation. Then the general solution is integrating y constant m star dx plus integration terms of n star containing only y is purely independent of x, means purely y term we require, dy equal to c. Substitute c value, the integrating y constant m star, that term indicate y m star, that is minus x upon y square dx plus integration. We require purely y term in n star, that is value of m star, that is value of n star. So first term has x and y both, then we cannot consider this value, consider only 1 upon y. Then replace 1 upon y at here, dy equal to c. Then integrate this term with respect to x, then minus x square by 2y square plus 1 upon y, which is ln y equal to c. Taking LCM, so minus x square by y square plus 2 ln y equal to 2c. This 2 goes upper side. Then ln y square equal to 2c. Now convert that term in form of logarithm. Then ln e raised to minus x square by y square plus ln y square equal to c dash, where c dash equal to 2c. Now simplify this term, and according to the properties of logarithm, we get e raised to minus x square y into y square equal to c dash according to the properties of logarithm. Then in addition form, then we write in form of multiplication. Now taking antilog means is equal to form, that is form of constant term. Then e raised to minus x square by y square into y square equal to e raised to c dash. We can also write as a c double dash. Then e raised to minus x square by y square into y square equal to c double dash or c dash or c, whatever. Taking antilog. Now y square equal to c into e raised to x square by y square. Here c is any constant. We can write e raised to c dash equal to c. That also constant, 2c equal to c dash. That is where c is an arbitrary constant. Now, these all are the examples you can solve as a homework. if you have any doubts regarding these examples, then feel free contact me. Thank you so much for listening this video.